I am doing well. Just went outside to take out the dog, and it is kind of nice outside. All right, we have a lot of stuff to get to today. Let's get going. First thing, whoops, not the first thing. First thing is we have off of school on Friday and Monday. So next week, Monday, we do not have a live e-session at this time. I did switch it to Tuesday from 2 until 3, and I know that not every student would be able to participate from 2 to 3 o'clock. Are you able to make Tuesday from 2 to 3? All right, then next week, Tuesday, we will have our live e-session on Tuesday from 2 to 3 instead of Monday from 2 to 3. All right, wanted to get that out of the way because we don't have school on Monday. All right, this is a problem from last year. It is only part A of the AP test question. It goes along with what, and obviously there's a B and a C section to this, but it says and when you get to the free response questions, you have to be able to pick out things that you need. They're all very similar the way you do the work. It's just can you pick out what you need in order to solve the problem? And that's where some students really struggle. In this problem, it says a company designs spinning toys using the family of functions y is equal to cx square root of 4 minus x squared, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of y is equal to cx square root of 4 minus x squared for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. Both the x and y are measured in inches. Now, today we're going to start talking about revolving this. So next week we'll have the same problem and we'll do part B. But right now, part A, it says find the area of the region. Okay, so now we're talking about last week's work. Last week's work, we talked about finding the area of the region between two curves. And it says, find the area of the region in the first quadrant bounded by the x-axis and the graph of y is equal to cx times the square root of 4 minus x squared, where c is equal to 6. Okay, so now they gave us a c value. So really, if you think about it, this is, so y is equal to 6x square root of 4 minus x squared. Every problem on free response really gets you to think about what's happening, all different types of calculus that you have to use in order to solve. Now, in this problem, I'm looking for the area. It would be nice if I knew what the distance is to here. So this is a 0, isn't it? So what makes this equal to 0? So if I put a 4 in here, or a 2 in here, 4 minus 2 squared, so that'd be 4 minus 4, which is 0. So this value here must be 2 comma 0. So I had to think about that, figure out, okay, I need it to equal 0, and that is either the 6x equals 0 or the 4 minus x squared is equal to 0. And if that is equal to 2, that would make this whole thing equal to 0. So now I have my value. I can go from 0 to 2, and this would be 6x square root of 4 minus x squared. Okay, so I've got to solve this thing. I've got to take the integral of this. How would I take the integral of 6x square root of 4 minus x squared? Do you have an idea? Take the antiderivative, okay? How? I mean, it's kind of a complex function. You should be saying u substitution. There's no way to take this unless we did u substitution on this thing. So I would set u, and this really should be dx. So u is equal to 4 minus x squared. remember we take the derivative of that. So du is equal to, what is that, negative 2x dx, du dx. And then if I rewrote this, this would be du over negative dx, or 2x equals dx. Remember u substitution? Then I would substitute that in there. So now I'd have the integral from 0 to 2 of 6x, and then the square root of u. I would put u in there, and then I would put du over negative 2x. That's 6, and that 2 crosses off to make a negative 3. So I'd have negative 3 here, and this x cross out. So I'm going to pull that negative 3 out in front. So now this is what I would have to be able to take an integral of. And I would rewrite that as negative 3 integral from 0 to 2 of u to the 1/2. Now I can take the integral of that. That would be u to the 3/2 times 2/3. So negative 3, and I'm running out of room here. So negative 3, 2, and then u, I'm going to put my 4 minus x squared back in there. 4 minus x squared to the 3/2 power over 3. So those 3's cross out. So I'm left with negative 2, and that is on the interval from 0 to 2. So now you have to be able to plug this back in. So if I put 2 in here, that's going to, oops, what did I do here? Is that right? I think I ended up with 0. So if I put 0 in here, I end up with, or if I put 2 in here, 4 minus 2 squared is 4, so that's going to be 0. That whole thing's going to be 0, so it's going to be 0 minus. Then if I put 0 in here, I end up with 4 minus 0, which is 4. 4 to the 3/2 is 8, I believe. And then 8 times negative 2 is negative 16. So the area of this should be 16. So now you talk about a lot of different things that come into play in this type of problem. I've got to be able to set the problem up. I've got to be able to figure out where the x value is. I have to be able to use u substitution. And then I have to be able to solve. Now, sometimes they'll let you use a calculator on these types of problems, but sometimes they don't. There's 4 problems, no calculators, 2 problems with calculators. So my answer should be 16. And here is the points that you would have gotten for that one problem. So you could have gotten a total of 3 points for that problem. Okay? So all the free response questions really dig deep into, do you understand the concepts that we've been working on? All right, now, there's another problem that I want to go through, and this is another free response question. I told you that we'd keep doing these types of problems. So what I'd like you to do is I'd like you to try this problem and see there's an A, B, and a C part to this problem. Let's just work it through because there's a lot to do in this problem. It says a continuous function f is defined in the closed interval between negative 6 and 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter of a circle at point 5, 3. And so 5, 3 is the center of the circle here. Right there. Okay, and then it says it is known that the point 3 minus square root of 5 is on the graph. If the integral from negative 6 to 5 is equal to 7, find the value of the integral from negative 6 to negative 2. Now this one, it's kind of weird because it's like, this thing doesn't even go back to negative 6. But we know, it tells us that between negative 6 and 5, the value is 7. They want to know what the value from negative 6 to negative 2 is. So if you think about it, if we took 7, so it's 7 from here to here is total of 7. Now if we subtract off this, we would be left with this, wouldn't we? So all I thought about is I thought, oh, if I did 7 minus this whole area here, I'd get my answer. Now, it's still not an easy problem because, I mean, look at all this area that we have to find. So we still have a lot to do in this problem, but it's doable now. I thought through the problem. I kind of figured out that my answer, this answer is going, or this answer here is going to be 7 minus the area here, okay? So what I did is I looked at this thing and I started thinking about, okay, what do I need to be able to find? And okay, so the area up here is 1, this is -1. And then if I took this area here and this area here, I think, I'm not exactly sure what I came up with there, but the hard part, oops, I need this part here. The hard part is this area here. And it's like, oh my goodness, how am I going to figure out what that area is? I mean, I can figure out this plus this is just 2, this, and you know, it's just, you just start adding the areas together. But this area here is the hard one. But when you think about it, isn't it a circle? Okay, because this is part of a circle, right? So isn't it just this part of the circle? So how do you find the shaded region of a portion of a thing? Well, it's the whole area. So the square, well, the square is going to be 1, 2, 3. So this is going to be 6 by 6. So that's going to be 36. The area of the square is 36 minus the circle. Well, the circle is pi r squared. Well, the radius is 3 here, so that's 9 pi. But it's only 4. It's a 4, because remember, we're not looking at this piece or this piece or this piece, just this one. So it would just be divided by 4. Where did the 6 come from? Well, if you take a look at this, let me get rid of this. If you take a look at this piece right here, this is a half of a circle, right? They told us that this was a half of a circle. Well, the rest of the circle would go like this, wouldn't it? So when it go, I'm looking at the square here. So this, if this is 3 up to here, this would be another 3 here. So it'd be a total of 6 underneath there. So the square is 6 by 6. So the square is a 6 by 6 square. That's where I came up with the 6. And then the circle has a radius of 3 because it's half of a circle. So that would give me 9 pi divided by 4 because it's only 1/4 of it. So this area is just going to be, what is that? What did I say? 36 minus 9 pi over 4. So this was probably one of the hardest ones that I've seen in a long time. It's one of those ones where, and you know, sometimes they'll put some crazy stuff in there. That's why it's like you try to get as many points for the free response questions as you can on each one of the problems, but sometimes they'll throw a doozy at you. And this one was definitely a doozy problem, no question about it. But I don't want to spend too much time on this one because we have 2 things to learn today. But that was an intense one. Okay, so this week we're going to talk about 2 different things. We're going to talk about the volumes of solids with known cross sections. That's part 1. And then we're going to talk about volumes of rotation. That is going to be part 2. So volumes of solids with known cross sections, what is that? Well, if you are given a base, so let's say I gave you, and this is super, super hard to explain. Let's say I gave you the square root of x. That graph looks like this. And let's say that I said that that is the base, okay? So that's the base of your object. And then what you're going to do is you're going to put semicircles inside here. So you're going to have these semicircles, hundreds and hundreds and hundreds of these semicircles. So we want to find the volume of this thing. Okay, and I do have a picture, kind of. That's not it. This one here. So this is what it would look like. So if I tried to put a bunch of semicircles onto the base, okay, remember the base I said was the square root of x. And in this problem, it went out to 9. It went from 0 to 9. And we put a bunch of semicircles on there. Okay, so you can see that there's hundreds and hundreds of these semicircles. How do you find the volume of that object? Well, it's super, the concept is very, very easy, but the math in it sometimes really messes with kids' heads. It is the integral from the start to stop, so 0 to 9. And then all you have to do is find the area of one of the circles. Now, you don't have to find the area of a specific circle, any one of the circles. You just have to find a formula to find the area of one semicircle. Okay, so if I was going to do this problem, the first thing I would think about is, how do I find the area of a semicircle? Well, a circle is pi r squared. That's the area of a circle, right? Pi r squared. So a semicircle would just be pi r squared over 2, wouldn't it? Okay, so in this problem, I can't have this variable in here, okay? I can't have r. What is r in this problem? And that's where students really struggle, because this is the formula to find a semicircle. But in this problem, what is the radius? So this is the radius here, right? In this problem, what is that radius? Okay, so if I put a semicircle right here, what is this radius? From here to here, or from here to here. It really doesn't make a difference. Radius is just that. So what is the radius there? I could put the semicircle right here. Nope. It's going to be you're going to have to use the equation. Okay, so what is this graph? Isn't this graph y is equal to the square root of x? Okay, so let me try to okay. So if you plug 4 in to this function, okay, if you plug 4 in, what's this value up here? 2. If you plug 8 in, nope, let's put 9 in. What's this value up here? 3. So isn't the radius just the square root of x divided by 2? Because I could ask you any value. I could ask you here, 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 I'd ask you here, but what would you do? You would take that number, you'd plug it in here, and you divide by 2. That would give you the radius of the semicircle. So in my problem here, I'm going to go from 0 to 9, and then I need to find the area of one semicircle. Well, remember, our semicircle is pi r squared divided by 2. What is r? R is this, isn't it? That's the radius. So if I work this out, what is r squared? Isn't r squared just x over 4? That is the area of one semicircle. That is what and I could write this as x pi over 8 if I wanted to. You have to be able to find the area of one object. If you can't find the area of one, you can never find these problems. So let's try this problem here. It says the shaded region, it's not shaded, is y is equal to x, and the line x equals 4 is shown in the figure. The region R is the base of a solid. So they're telling you this is the base, okay? This is the base. right here. And what you're going to do is you're going to try to find the solid. For this solid, cross sections are perpendicular to the x-axis, are rectangles whose height is 10 times its base. So I'm going to draw one rectangle, because that's all I need to be able to find. I need to be able to find the area of one rectangle, and that's how I draw. So it's going to be the integral from 0 to 4 and the area of one rectangle. Okay, so what's the formula for rectangles? Length times width, or could you say base times height? That's the same thing? All right. So I have to find the area of one. What's the base? What is the base of that rectangle? And that base goes from here to here. What is square root of x? That is absolutely correct. What is the height? And they tell us what the height is. They tell us that the height is 10 times its base. So what is the height? 4 squared of x. No. The height is 10 times the base. Well, wouldn't that just be 10 squared of x? Because the base is square root of x. Yes. So now I have 10 square root of x. So if I multiply this together, don't I just end up with 10x? Because square root of x times square root of x is just x, isn't it? That is how I would find. Now, if I took the integral of that, I'd have my answer. So when you're finding the volume of something that has a base, all you have to do is find one, the area of one. Now you have to find the area as an equation, right? You're not going to be able to find it without an equation. You're going to have to use an x. Now, I don't know if I erase it. Oh, this problem here. Okay. This problem is a doozy. It says, let R be the region bounded by the graphs of the sine of pi over x and y is equal to x to the third minus 4x as shown in the figure. Okay, so this graph, this one up here, and let's go in red. This one in red is the sine of pi x. This one down here is x to the third minus 4x, as shown in the figure. It says the region R is the base of the solid. Okay, so this is the base. Each cross section perpendicular to the x-axis is a square. So if I draw it in here, it's a square. If I draw it over here, it's a square. All I have to do is find the area of one of the squares, and then that does it. So my integral would be 0 to 2, okay, because I'm going from here to here. But now all I have to do is find the area of one square. Well, what is a square? It's just x squared, isn't it? Or base times base. I don't care how you say it, but how do you find it? That's the question. So, what is the area of one square? What is base times base? And this is a little bit more complicated because some kids, they just don't know. Top minus bottom squared. So you're saying sine of pi x minus x to the third minus 4x squared? I'd say you're right. Because the top minus the bottom will give you the difference in between those two functions. Very good. That is absolutely correct. So if I wrote, and I'm not going to solve this, but this is going to be the sine, of pi x minus x to the third minus 4x. Now this I would assume would be, I better put this inside parentheses, this I would assume would be a calculator-based problem because there's no way you're going to work that out in the amount of time that they give you. But that's absolutely right. You just find or to find that volume, just top minus bottom. Good, excellent. So that is how you find the area when they give you the base of a thing. You need, oh yes, I do. Yeah, because this would just be one side, right? So we'd have to square it. Yes, you're absolutely correct. You'd have to square that. If you didn't square it, it would not be correct. All right. So that is one concept for this week. Second concept is volumes of rotation. If I gave you, let's say I gave you this equation, y is equal to x, okay? Y is equal to x. And I said that this distance here is 4, so this would be 4, 4, right? This point would be 4, 4. Now, if you took this, it's a triangle, isn't it? And you rotated this around the x-axis, okay? Can you visualize that in your head? Just rotating that around the y-axis. What figure would you get? What figure would you get? It would be a cone. It's absolutely right. This would be a cone, and I'm going to rotate this up. No, I won't. I'll just write it. I'll just do it like this. So it's going to be a cone. Okay. And in this problem, how do we find the volume of a cone? Do you remember the formula for finding the volume of a cone? Okay. Anytime you're looking for a volume, it's always the area of the base. So that's pi r squared. Okay. Times the height. And if it's a cone or a pyramid, divide by 3. So this is the volume. This is how you find the volume of a cone. In this problem, what is the height of this cone? 4. What is the radius of this cone? 4. So I should be able to find the volume of this cone, right? Volume is equal to pi times 4 squared times height, which is 4, divide by 3. So that is going to be, what is that going to be? 16 times 4, which is 64, divide by 3. So my answer would be 64 pi divided by 3. Do you agree with that? That is the volume of that cone, if my math is correct. Okay. Now we're going to use calculus to do the exact same thing. Now calculus tells us that all we need is one radius. So we're rotating this thing along the x-axis, right? So what we do is we just take and draw a radius in. That's my radius to the x-axis. What is a radius in this problem? And what I'm asking is, generically, what's the radius? So if I put it here, I'm not asking for a number. If I put it here, so what is the distance from here to here? It's just x. It's not y is equal to x. It's just x. Okay? This is x. This would be x. This would be x. So the formula to find the volume of a function rotated about an x-axis or a y-axis is just pi times the integral of radius squared. That's it. That's the whole formula tonight. Now next week there's gonna be a hole in there. We'll be able to rotate something, and there will be like a cone that you would see on a street corner. There's like a in between there. There's a gap, right? we'll be able to do that next week. But this week, they're all solid. They're all going to be a solid thing. But this is it. It's just pi times radius squared. Well, we know what the radius is. It's just x. So this is going to be pi integral from 0 to 4. I'm going to have to make my marker a little bit smaller here because I'm not going to have enough room here. Okay, and that's going to be x squared. All right, so now I'm going to write it up here. Pi 0 to 4 of x squared. Guess what? I know how to take an integral. That's just x to the third over 3, isn't it? So I've got pi x to the third over 3 on the integral from 0 to 4. So I'm going to plug 4 in here. 4 to the third is 64 over 3. And then I'm going to put 0 minus. If I put 0 in there, that's 0. I still have that pi on the outside. So my answer is 64 pi over 3. Is that the same thing as we got right here? And the answer is, yeah, it's the exact same thing. So this, when we're finding volumes, this is the set of notes that you need. Pi times integral r squared. Okay, so let's say I gave you a real easy one. I always like doing ones that geometry, we can solve it using geometry, okay? So let's say I gave you y is equal to 4, right across here, just this line. And I'm going to take that all the way out to 6. So if I rotated, let's say I took this line and I rotated it around the x-axis, what would I get? What would that turn out to be? That volume, if I just rotated that and it's a solid and we rotate around the x-axis, what figure would that be? Cylinder. That's exactly right. So it would look something like this. Okay, and in this problem, okay, what's the radius? It is 4. What is the height? 6. So in order to find the volume of a cylinder, it's just pi r squared times height. We don't divide by 3 because it's not a pyramid or a cone. So in this problem, this would be 16. So pi 4 squared times 6. So that's 16 times 6, which is 96 pi. Okay. So now I'm going to use calculus to solve this. 0 to 6. Again, all I have to do is draw in one radius. Well, what is that radius? Well, this problem, it happens to be just, it's always going to be 4, isn't it? My radius is always going to be 4. Doesn't matter where I put it. So this is just going to be 4. Remember, we have to put a pi on the outside. That's my formula. Oops, and squared. Because it's radius squared. So my problem, I have pi 0 to 6 of 16 squared. I'm sorry. 4 squared is 16. So now if I take the integral of this, integral of 16 is 16x. An interval from 0 to 6. Put the 6 in there. 16 times 6 is 96. I still have that pi. Lo and behold, I get the exact same volume for my answer. So this, tonight, pi integral r squared. Now next week, there's gonna be a hole in there. Okay, so let's say we had something like this. We had y is equal to 6 now. So we have y is equal to 6 and y is equal to 4, and we're going to rotate this thing about the x-axis. Well, guess what? This is going to be a hole. It's going to be blank in there. It's just going to be, I don't know what figure you would call that. I don't know if you, like a washer. A washer has a hole in it, right? And I don't want to you know, so those are things that there's going to be holes next week, and it gets a little bit more complicated. But tonight, there's pretty straightforward. Okay, so here's, now obviously I was going through really simple, simplistic ones, but you know, if you have a figure like this and you rotate it around, you end up with something like this. We can find the volume of this as long as we know what the radius is of that function. So the disk method, basically, this is the notes for finding the volume. So volume is equal to pi times the integral from a to b of radius squared. That's it. All right. So let's try some problems. These are all, and you can go through this problem if you want to, but let's try our own. So here's a problem. It says find the volume of a solid generated when the area bounded by the curves y is equal to x to the third minus x plus 1 and x equals, oh, this one's going to have a hole in it. Can't do, oh no, I guess that's just here to here. Okay. So this graph, so here is my, so this right here, oops, this right here is y is equal to x to the third minus x plus 1. So that's the curve. This is the x-axis right here. And we're going to go from -1 to +1. I'm going to rotate around the x-axis so it looks like a vase. So if I wanted to set this up, super easy. -1 to 1. My radius is just going to be this equation, right? Because from here to here is any value I put in here gives me the height of that function. So this is just going to be, oops, I better put a pi on the outside. I always forget to do that. X to the third minus x plus 1, all raised to the second power. Now, this is definitely a calculator-based problem. They would not ask you to find this, because this would be a very difficult problem. You'd have to FOIL this out, and then you'd have to find the integral of each piece. That's not usually how it's done. Now, some of the problems, yes, they'll ask you to not use a calculator. And I think on the assessment this week, I do ask you to do a couple problems without a calculator. How do I know if you use a calculator? Your answer will be a decimal. It's real obvious when kids use calculators, because you know, instead of coming up with like 16 pi, they'll give me like 48.325. It's like, oh, okay, you use the calculator. I know that, because when you don't use a calculator, you're gonna have pi in your answer. Just very obvious when kids use that. All right. So now, do you remember the last problem that a couple, like maybe 10 minutes ago, we did the exact same problem, but we did it as the base of a solid were rectangles? Okay. This was a problem on an AP test. Part A was the base of a solid. You had to find the volume of the solid with the given base were rectangles. Now this time, part B, it says find the volume of the solid generated by revolving R about the x-axis. Okay, I want you to work on this as much as you can. See what you get for an answer. Do not use a calculator to come up with an answer here, okay? So revolve this around the x-axis. The y is equal to square root of x. Revolve that around the x-axis. See what you come up with for a volume of that. And what would, now, and this is, some kids cannot do this. They can't look at this and say what the figure would look like, okay? If you revolve this around the x-axis, okay, so I'm taking this, I'm revolving this around the x-axis, what would that look like? What kind of figure would that be? Any object that you know would look similar to that? A cone, but not super sharp. Okay. I was thinking, have you ever seen a thimble? It would be sort of like a thimble, wouldn't it? However, a thimble are usually empty inside because your thumb goes in there or your finger or whatever goes in there. So, but this one's going to be solid. So, yeah, maybe I don't like talking bullets, but you ever seen a bullet for a gun? That would be basically the shape of it. Half of an Easter egg? Okay, I would go with that. All right, so I'm going to stop talking and I'm going to let you try to figure this out, okay? See what you get for an answer, and then we'll go through it step by step. All right, you're done already? My goodness. All right, I did not do the problem yet. Okay, so I'm going to do the problem. Integral from 0 to 4. I've got pi here. My radius, all I need is one radius. The radius is square root of x, right? So that's going to be my radius, and then I'm going to square it. Oh, that's awesome. I love squaring a square root of x because that just gives me x. So I've got pi 0 to 4 of x. Take the integral of that. Well, that gives me x squared over 2 on the interval from 0 to 4. I'm going to plug 4 in here. 4 squared is 16. 16 divided by 2 is 8. Minus, put 0 in there, 0, 0, that's 0. 8 pi. You are absolutely correct. That is the correct answer. So now, that's the concept. Okay, you've got it. Do they get harder? Absolutely. Now, these can't get much harder because now next week, what we'll have is we'll have something like this. There'll be 2, and then they'll say, okay, so the second equation is y is equal to, let's say, I don't know, 1/2 x. So you're going to have to find the radius here, which is a little bit tougher, but I think you'll be able to do it. Wouldn't this small little radius be the square root of x minus 1/2 x? And then, and it's called big radius. So next week, because we have to subtract off this part, right? Because if you think about this thing rotated around, this is going to be empty. It'd be something like a wine glass. If you think about holding a wine glass sideways, because you're going to rotate this around, the whole middle is going to be empty. So I think about like a wine glass kind of thing. So next week we're going to do big R minus small r. So this would be from here to, oops, let me use blue. So from here to here is called big R. This here is called small r. So next week it's big R squared minus small r squared, because we're going to subtract off this part. So that's where we're going next week, is we're going to be talking about finding volumes when there's a hole in the middle of them, or it's like there's blank in there. But this week, not like that. All right, so here's another problem. I want you to solve this one. It says y is equal to negative x squared plus 1, and y is equal to 0. That's what, so you're going to revolve the shaded region around the x-axis. What is the volume of that? Okay. And I'll let you work that one out and see what you get. And this one should be done without a calculator also. Ooh, that's going to make it a little bit tougher though. You'll be able to do it. Ooh-wee. That's a little bit tougher, isn't it? All right. You can continue working. I just started working on it. 16 over 15 pi. All right, let's see. Let's see how we do. In this problem, I'm looking at this and my radius is negative x squared plus 1. So I've got the integral from negative 1 to 1 of negative x squared plus 1. That's my radius squared. That's going to cause some problems for some people. So negative x squared plus 1 times negative x squared plus 1. So what does that give me? X to the fourth minus x squared minus x squared plus 1. So x to the fourth minus 2x squared plus 1. Okay, did you get that for your radius squared? All right, so now I have the integral from negative 1 to 1 of x to the fourth minus 2x squared plus 1. Got to take the integral. So x to the fifth over 5 minus 2x to the third over 3 plus 1x from negative 1 to 1. I still have pi out here. I always forget to write that in. So if I put 1 in here, that gives me 1/5 minus 2/3 plus 1 minus, and then I have to put the negative 1 in here. So negative 1 to the fifth is negative 1. So that's negative 1/5. And then if I put negative 1 in here, that gives me negative, so that's going to be negative 2 over 3. So that's going to be positive 2/3 plus negative 1. Now I have a minus out here, so I'm going to change it and change all these signs. So that's positive, that's negative, that's positive. So 1, so I'm going to just add this, so that gives me 2/5. The negative 2/3 and negative 2/3, it's negative 4/3. And the 1 and the 1 is 2. Okay, it doesn't give me, all right, so now I need a common denominator of 15. So this would be 4/15. Nope, that would be 6/15 minus 20/15 plus 30/15. So that's 16/15 pi. Holy moly. That is absolutely correct. Now, that's a lot of, what you're talking about there is you're being able, there's a lot of math involved in that problem. You've got to take an integral. You've got to be able to plug the value back in. Excellent job. Very, very nice. Love it. All right. Now, the rest of this week, we're reviewing derivatives. Now, derivatives, we've got the chain rule, we've got the power rule, we've got the quotient rule. Okay. Hopefully you remember all of those things. The problems that you'll see, something like this, 2x sine of x. How would I take the derivative of this problem? Okay. How would you take the derivative of that? Product rule, absolutely. U is equal to 2x, u prime is equal to 2, v is equal to sine of x, v prime is equal to cosine of x. Inside, so 2 sine of x plus outside 2x cosine of x. Okay, so that would be letter D, looks like. So you have to remember the product rule, the quotient rule, all those different types of derivatives that we've taken. And this week is kind of review using those types of rules. How about this problem here? What is the derivative of 5x squared minus 2x to the third? What would you use in order to find the answer there? The chain rule. Boy, this week you are really, really on top of things. Absolutely. I would bring the 3 down, leave the middle alone. So that would be 3, 5x squared minus 2x to the second power times the derivative of the middle. And that would be 10x minus 2. And that would be my answer. Do they have one that looks like that? 3. Oh, they multiplied the 3 they multiplied the 3 through here. So they have 5x squared minus 2x to the second. And then they multiplied the 3 through this parenthesis instead of the first one, which is perfectly fine. 30x minus 6. So it looks like I'm right here. 5x squared minus 2x squared. Right there. That is it. Holy moly, I thought it was going to take us a while longer to get through this stuff, but that is a lot of stuff that we went through today. Finding the volumes when you know a known base, and then finding volumes of rotation. Next week, we're going to be doing volumes of rotation when there's holes in the graph. And I think that's about it. And then we start reviewing the rest of the time. I think we start reviewing for the final exam, or not the final exam, but for the AP exam. We are getting to the end here. Any questions? All right. Have a great Easter vacation. Bye.